Hello, my name is Santiago Fernandez. I'm a junior and I'm majoring in computer engineering. I designed my database so that it would resemble online grocery shopping, where the customer can create an account with the store and they can browse through all of their available merchandise. They can add whatever they wish to purchase to their carts, and lastly, they can enter their payment information and pay. I decided to do my project on this just because this is something that has been on my mind recently and it made a lot of sense. Online services like grocery shopping have become very popular recently, and my family began using online grocery shopping very frequently ever since COVID-19 started. So the first thing is the ER diagram. The first entity here is customers. Every customer is identified by their email address, and their other attributes are their name, their zip code, their phone number, and the password to their account. This is the information that the customer would enter if he was creating an account with the store. Customers order carts. Every cart is identified by its own number, and the other attributes are the date of the order, the shopper ID. Every cart is put together by a shopper, which is someone who does the shopping for the customer. The status of the cart, whether it's been delivered yet or not, or it's still being put together by the shopper. The time that the delivery was made. Any comments that the customer might have for the shopper. The ID of the store that the cart was bought from, and the email address of the customer associated with the cart. This is the cart info entity, which describes the actual contents of every cart, whereas the carts entity describes the other information that I just described. The cart info entity, the primary key of it is the cart number and the item number together. And there's also the price of every item in the cart and the quantity of each item in the cart. This is the items entity. Every item also has its own number, and there's also the name of the item, the brand of the item, and the category of the item, meaning things like meat, dairy, breakfast, things like that. Items are stocked by stores. Every store has an ID, and there's the address, the service hours, the time that the store is open, the phone number of the store, and the rating that people have given the store out of 5 stars. I split up the address attribute into the name of the street, the city, the state, and the zip code, so that if someone wanted to search for a store in their specific city or zip code, they could do that. The relationship stocks also has 2 of its own attributes, price and quantity, and the reason why I included these attributes here and not here or here is because different stores might sell the same item at different prices, and they might also have different quantities of the same item stocked. Stores have employees working for them. This is the entity with the most attributes. Every employee has an ID, and beyond that is their name, their birth date, the ID of the store they're working at, the position they're working at in the store, which can be things like cashier, stocker, someone who stocks the shelves, shopper, or manager, which is why this self-referencing relationship is here. Every store has a manager, and the rest of the employees report to the manager. There's also the email address of every employee, their phone number, their wage, and the date that they were hired on. Finally, customers make payments. Every purchase made by a customer has its own number, and there's also the email address of the customer that made the payment, the cart number, which identifies the cart that was purchased through this payment, the address that the cart was shipped to, the credit information of the credit card information of the customer, the card number, the name on the card, and the expiration date of the card, the amount that the customer paid, including taxes and everything, and the date that the payment was made on. This is just another way to represent the database. These are the 8 tables that would need to be made in order to satisfy this diagram, and these are the queries that we're going to be making. So this is the actual code for the database. This is the code for the customers table. These are the customers. This is the code for the stores table. There's 3 stores, a Cooper City store, a Miami store, and a Winter Park store. There's an employees table. This is the code for the carts table. And this is what I was referencing when I said that customers can leave comments to their shoppers. An example of that would be if vanilla ice cream is not available, then replace with chocolate. Please make sure that the bread is fresh, things like that. This is the code for the items table. These stores sell 37 items. This is the cart info table, which details everything about all of the carts. This is the stocks table, detailing how much of every item every store has stocked. And lastly, this is the payments table. These are all the payments that have been made to these stores. So based on this code, we can make queries. We can find the name of the manager of the Miami store. If we run this query, we find that the name of the manager of the Miami store is Fleur Travis. We can find the names, brands, and prices of all the items in the category breakfast from the Winter Park store. So if someone was shopping at the Winter Park store and they wanted to see all of the items that were being sold that pertain to breakfast, they could run this query. And these are all the items, all of the breakfast items at the store and their prices. We can find the store selling milk for the cheapest price and the price of the milk assuming milk is in stock. So if a customer wanted to know what was the best store to go shopping at, and he would base that on who was selling a certain product for the cheapest price, he could run this query. And we learn that store number 1, which is the Cooper City store, is selling milk for the cheapest at $1.99. We can find the IDs of the items and their stores that need to be restocked, along with the quantity of the item left. So from the perspective of an employee, if he wanted to find out which stores needed which items restocked, considering that if there's less than 10 left, they need to be restocked, we could run this query, and we learn that store 2 needs these 2 items to be restocked, and store 3 needs these 2 items to be restocked. We can find the names and emails of all the return customers who have made more than one purchase, and the total amount of money they've spent. So if, for example, a manager or something was considering a rewards program for his best customers, he could identify them with this query, which tells us that these are the 2 customers that have shopped at his stores multiple times, and they've contributed a substantial amount of money. So this is my project. Thank you.